Okay, well, welcome to yet another session on MySQL tuning. Isn't it amazing that for a database that you can set up in 5 minutes, there's all these sessions about tuning and it never ends? Let me tell you this, it won't end with my presentation either. It just goes on. But what I can do for you and what we're going to discuss here is some quick, easy tuning fixes you can do to get started and go from there. So why real world? For obvious reasons. Everybody starts off with the default MySQL setup, which runs fine in dev. How many of you are DBAs here? Show of hands. And how many developers? All right. So when I say it runs fine in dev, some of you would be expressing frustration and some of you would be laughing, right? As a DBA, when somebody tells me it runs fine in dev, I laugh. As a developer, I get frustrated, and I've seen both sides. But what happens is that's pretty much the only testing that you get, and then you launch it with the default setup. The application grows, there's performance issues, you don't know what to do, and 9 times out of 10, MySQL is set up as a sysadmin. I myself have a sysadmin background. I just got deeper into the database side and then went down from there. But that's when you look around for a DBA, that's when Pythian comes in, that's when we come in, and that's when we start with tuning, and that's real world. And we have our constraints. The database is in production already. The SQL cannot be changed. The data model cannot be changed. Well, it can't be changed overnight. So you have to work with limited downtime windows. You have to tune quickly, effectively, get the most bang for the buck, and of course it has to be done yesterday. But basically what you're trying to do is get people over the hump so they can then start looking at some of the changes that might require a code re-release, might require a re-architecture, or at least get them to the point where their next release, which is in the works, has time to mature, be tested, and be deployed. So this is what we're going to discuss. We're going to go over some of the parameters, or variables as they're called, some of the status feeds, some of the output from MySQL that tells you how it's performing. Then we'll go into some general parameters, some MyISN parameters, some InnoDB parameters, some tips to get you started on tuning, and questions is at the end, but if you have any questions anytime, feel free to interrupt. We'll try to make this interactive. Okay, list of parameters in the handout. It's not on the handout. There is no handout, I didn't know that. It's in the blogs, and that's the link to the blogs. If you go to the blogs, actually just www.pythian.com/blogs, you will also find these slides if you want to download them as a PDF. You can see the parameters with show variables, which is now show global variables, and the status with show status or show global status starting with 5. I'll quickly show you what it looks like because it's very hard to talk in a vacuum. So if I go, and that's what my default setup is on my system here. This is obviously a huge list. You can do a page and you can go see that bit, or you can filter using like with a %, name %. So if you want to look at InnoDB parameters, you can say show global variables like %, InnoDB %, and that'll show you everything that has InnoDB in it. Go look over the full list, and it's also on the MySQL site. They have parameters where they apply to, whether they can be changed online, which means you don't need to restart the server, or they cannot be changed online, which means you have to restart the server. So this is again the same thing. You can do a filter on like, and this is how it looks like. So let's start with some of the basic parameters that you're trying to tune on a default setup. The first one, max connections. Obviously you've all seen it. The web server grows, opens a new connection, can't get a connection, client gets an error, everybody panics, and the only thing that is limiting it is max connections in the database. The reason why max connections is limited is because each connection can use up a certain amount of memory. And we'll come to that later, how much memory each one can use. But if this was set unlimited, and you did allow unlimited connections to come in, you would run out of memory eventually, and things would just basically go out of hand. So if you want to check how many connections you're using, whether you need to increase this parameter or not, that's provided you haven't already found out on the web server. You look at max use connections. On the other hand, you can also look at max use connections and see if you want to reduce this, because you can use the memory gain to some other use. The next one is table cache. Now, each query that runs has to open a handle to a table. That is an expensive operation. So what MySQL does is it caches those tables. Now obviously, how many file handles are open at a time depends on how many concurrent queries you're running, how many tables each of those queries is accessing. Even if two queries are accessing the same tables, they will open separate file handles, or they will need separate file handles for each of the tables that they're hitting. And what you look at is for how many tables are open and how many have been opened. Opened is historical, it just grows. But it should not grow too fast. If it's growing too fast, it means you're not caching enough file handles. So you need to increase table cache. This will be very evident on some of the slower I/O subsystems like NFS or something. If you're using any of those net filers, you will really see a lot of queries in opening tables state. And if you have tables cached there, it's going to make a big difference. There is an open files limit, which is an OS setting, which you check with ulimit. So just be careful you don't hit that, because MySQL is really going to complain in a bad way if you do. Similarly, every connection that comes into MySQL spawns a thread inside of MySQL. Starting those threads in MySQL is another expensive operation. So you want to cache these threads. If you set a thread cache size of anything greater than 0, MySQL will keep that many threads ready to run. So when a connection exits, it won't destroy a thread. It will hold it and reuse it for the next connection. This actually sometimes works better than connection pooling on your app side, because it's inside the database. In a lot of cases, we have seen no performance degradation by switching out of connection pooling to a bigger thread cache on MySQL and just opening a connection as required. It doesn't mean that you open a connection for every little query you do, but for most applications, it does work well. With connection pooling, sometimes there is a mismatch between what the database thinks the connections are and what the connections pooling software thinks they are, and we run into more issues with that. So you might want to look into that. And again, just the same as with open tables, there is threads cached, which is how many threads are in the cache and how many threads have been created. So threads created should not go up too fast. If it goes up slowly, it's not a big issue. When I say slowly, it's maybe 5, 10, 15 an hour. You'll get to judge that. This one is a big one if you've got a lot of repeated queries on data that doesn't change often. I've seen this come in most useful for some reason on Java, because somehow it seems to do the same queries over and over again. If you're using any kind of Java in your app, you might actually want to look into this. What happens is, if the query hasn't changed, which means the query is exactly the same, the variables are exactly the same, MySQL just looks at the query and says, hey, I've seen that before, here's the result, and just passes it without actually going down to the database itself. It just gets it out of the query cache and sends it back. So it's very fast, it avoids a lot of expensive operations. It does have an overhead. So don't just blindly turn it on. If you're doing caching in the front end, this will probably not help. What you need to look at is how many hits you're getting versus how many inserts. If you're getting a lot of inserts and a lot of hits, it's probably not very good. You need to get a few inserts with a lot of hits for it to be really useful. If you're getting a lot of well, the size of this depends on another status variable that's called query cache low mem prunes, which is, I haven't shown that here. But if you look at that, you will see how many queries that have been thrown out of the query cache because there wasn't enough memory. So that's something you need to look at when you work on the size of this. If you are using the query cache and you're seeing a lot of queries being aged out just because of size, you might want to look at increasing the size a little. If you're not using it, turn it off because there is an overhead for every query when this is turned on. Then I'll come to what we call buffers. Buffers are per thread, which means that's per connection. So every connection can have its own set of buffers. These are used for sorts, for table scans, joins. There's a lot of buffers, and look at the memory usage. You take each of those buffers, you add them together, and then you multiply with the maximum connections. And that's why I said you just don't increase maximum connections blindly, and that's why it's limited. Because if you can calculate this, you know how much memory potentially your database is going to use for the buffers. We'll come to caches later, and that memory has to be added to this to give an overall total usage for MySQL. But that cache memory doesn't depend on the number of connections. That's a global setting. So the question we run into most often is, if you add up all these buffers and you multiply with the number of connections, you come up with a ridiculously high figure, and you add the cache, and it's more memory than there is on your server. And is that okay? To a certain degree, it is okay. It depends on what your application is, what your load profile is, but a little bit of overcommitting is okay, because if you've got a max connections of 1,000, it's very unlikely that all 1,000 connections will be using all the buffers at the same time. It doesn't mean that it cannot happen, it just means it's very unlikely. If you're really, really paranoid, don't overcommit. But in real life, it's not easy to get all the memory that you need to allow this to happen, so you will end up overcommitting a little. So some of the important buffers, sort buffer size is a big one. It's used for order by or group by clauses. So if you have that in your query, MySQL is going to try and do it in memory. If the sort doesn't fit in memory, it's going to go down to disk. And if it goes down to disk, it's going to be very, very slow. So look at what your sort buffer size is, and if you need to increase it, increase it. If you can avoid order by or group by clauses, avoid them. You don't need a sort buffer. But that's not how it works. If you look at sort merge passes, that tells you how many sorts are going to disk and how many times the data is merged in memory. So the more you get, the higher the value of sort merge passes, the more chances are you need to increase your sort buffer size. If your sort buffer size is already high and you're still getting a lot of sort merge passes, you have to go back to the application and see why you're sorting so much data you shouldn't be. Similarly, there's a join buffer size, which is for joins that do not use indexes. Why would they not use indexes? Create an index. But if you have to do joins like this, let's say for a query that doesn't run very often, and you don't want to have the overhead of an index for this, just this one query, you can try increasing the join buffer size, and hopefully that will mean that the join will happen in memory, and it will give you some optimization. An index will of course be faster, but then it has other side effects. And you can see how many full joins you're doing by the status variable, select full join.
A question?
Yep.
So can we set these at the client per session?
You can set these
so
per session.
in our programs, if we knew we had a particularly
Yes.
expensive query, we can do it right at that point in the program, right?
Yeah.
Okay.
You can do it that way, but if you go back to my constraints, I can't change the program, right? So if you go back to my constraints that I listed when I get...
Oh, yeah, changing it later.
Yes,
Gotcha.
it's something that I just cannot...
Yeah, no, I know what you're talking about.
So I have those limitations. You can do these on a per session basis, and that's the best. If you need a big join buffer for a particular query, set it at the session level.
Okay.
Then you have the read buffer size, which is for caching raw data. during a full table scan. Again, this will only help for full table scans. So you might want to play with it to see if it helps or not. Usually I haven't found much use out of this. Temp table size on the other hand and max heap table size, these two are related. These two are helpful again for when you do group by sorts. We had the buffers earlier, but these also decide in conjunction with the buffer size as to when a sort or a group by will actually spill over to disk. Even if you have a big sort buffer and you can't create a temp table of the size that's required, it will spill to disk. And same thing with the heap table size. And I was talking to Jay earlier about this. Nobody seems to know what the correlation is between the two. The document says you have to use the minimum, but in practice that doesn't always work. You have to set the heap table size higher than the temp table size for this to work effectively. You will look at the status variables, create temp tables, and created temp disk tables. Temp tables are in memory, disk tables are on disk. You don't want temp disk tables. If you're doing a lot of disk tables, you have an issue with one of your buffers, with your temp table size, your heap table size, or your queries in general. Now we come to what's called the global caches. MyISM, the biggest tuning improvement you can do is the key buffer size. Key is another name for an index, for those who are wondering. Indexes do speed up queries, we all know that, and it does help if those indexes are actually in memory because MySQL doesn't have to go to a disk seek just to find a leaf block for an index. So you want to basically pin as many indexes as you can in memory. This value you can set, if you're only using MyISM, 30-40% of your memory can easily go to the key buffer. If you don't have that much memory to give it, if it's a mixed database, you can set up named key caches, which will work outside of the key buffer size, and you can pin specific indexes into those named key caches. So if you've got a table you know is used very often, you don't want the keys, the indexes to be aged out of the cache, pin them with a named cache. And the added advantage is you can preload those indexes on startup. So when you start up the database, it's got no queries, immediately the indexes are cached and it doesn't have to go to disk again for those indexes. So the syntax is all here in the slides. You can look it up or you can look it up in the documents. Just remember the last line because that's not easy to find. There's actually two parts to the statement. The first one says cache this index in my named cache, but it doesn't preload it. You have to do a second load index into cache to actually get the preloading to happen. Preloading is optional because when the index is needed or as it's needed, it will be cached, but it does help to get it in ahead of time. InnoDB similarly has a few parameters that you can tune, and again, this is the biggest is the buffer pool size. It's sort of like the MyISM key cache, as in it caches data, but for InnoDB, it caches index and table data. The reason it does that is because indexes in InnoDB are a little different. They're always clustered indexes, so the leaf node is where the data row is. So when it's reading the index, it also reads in the table data and caches them both together. In fact, that's one of the things you need to look out for when you're designing an application for InnoDB is how you define the primary key, because InnoDB will use the primary key to store the data. So you want the InnoDB primary key to be short and tight, integer. Don't set a multi-column InnoDB primary key if you can help it. And also setting a big primary key for InnoDB wastes space because all the secondary indexes don't actually contain lookups to the row data, they contain lookups to the primary key. So you end up getting the primary key anyway, even if you're using a secondary index on the table. So you really want your primary key to be as small as possible, as compact, as tight.
So I got a question.
Sure.
So with InnoDB primary keys, it's clustered on the page in basically in primary key order, is that true?
Yeah, that is true, yeah.
So if we can use a key that's in our data that matches a sort order that's good for our searches, That's
Yes.
probably better than using an auto increment, is that true?
It is, yes.
Okay. Well, because sometimes that might be, you know, I always read you're supposed to make it really short, but sometimes that might not be that short, but it might be a sort that you need to do.
That's right. If you can force a sort to use an index, that's probably the best. And sometimes we do recommend multiple keys just for that reason. Because if you're doing a lot of sorting and you can avoid a file sort at a temp table. Just to elaborate on that point, if you're doing an ordered by clause and the ordered by clause is part of your where and it's indexed, and that's the index it's using, it can actually use the index to sort. So you don't need to go to disk, or you don't need to create a temp table, and that's always faster. What I'm giving you is general tips. It'll get you started. You really need to look at your application and figure out exactly what it is. I'm not saying that you always have to have an auto increment for a primary key. I'm saying it does help. But if you're doing sort by and it's improving that, think about any other query that might be affected by that as well. Because if there's a lot of secondary indexes and you're doing lookups on that, and you come back to the primary key, which is much wider, it might not help that much. The second parameter that I want to focus on is the log file size. The way InnoDB works is every transaction is written to the log file and it's written into the buffer pool, but the modified data is not sent to the data file right away. So it only does one write to the log file and one into the memory. It's only when there is a checkpoint that it takes all those dirty pages out of the buffer pool and flushes them to disk. So it avoids a lot of I/O. It avoids a lot of random I/O because it's doing sequential writes to the log file. And that really helps speed up transactions. But if your log files are too small, then it will checkpoint very often, because it checkpoints whenever there's a log file switch. When it's filled up a log file, it's sequentially writing them. It'll go to the next one, and it'll flush all the data from the buffer pool into the data files, and it'll say, okay, this log file I don't need anymore, so it can be reused. But if your log files are too small, it's going to be checkpointing all the time. There's going to be very few dirty pages in the buffer pool, and you're not going to get efficiency out of your database. So increase the log file size. 25-50% of the buffer pool is fine. It looks very big when you start out, but I've seen 1 gig log files, and that's not uncommon. 512 megs for 4 to 6 gigs of buffer pool is quite standard. The downside to that is crash recovery, because if MySQL crashes, think about what I just told you. It's only writing to the log file and to the memory. The data file doesn't have that updated information or the updated rows. So when you start up InnoDB after a crash, it's going to see where the last checkpoint was, look at all the data in the log file that's after that checkpoint, that's not committed to the data files, and start writing it, reading it out of the log files, writing it to the data files, and until that's done, MySQL won't finish starting up. And that can take time. I have seen crash recovery take upwards of 30 minutes, 40 minutes, and you just have to sit there and wait. There's no option. So it's a little bit of a trade-off, but given that hardware is generally very stable, MySQL is generally very stable, you won't see too many crashes. So hopefully that time will be down. And if you do see a crash, you can always promote a slave and then rebuild the master after if you have to. You can promote another slave to the master. It'll be much faster to start up. There's another parameter that comes in with big transactions, that's the log buffer size. And so when you're running a transaction, MySQL will write the transaction log into the log buffer. It's only on commit that it will flush it to the log file, or when the log buffer is full. So if you have a small log buffer, you'll be doing a lot of writes to the log file if you have big transactions. So if you have big transactions, use a big log buffer. Yes? The log file data is sent to the log file on commit, but it's not sent to the data file till a checkpoint. That's right. Yeah, it doesn't do itty bitty writes to the data files. It does them to the log files. If you want to have log files on dedicated disks, it actually might help if you have small transactions. Yes?
So I have a hard time sometimes figuring out the difference between the InnoDB log file and the bin log and how the bin log plays into this. Can you give me a hint on that?
The bin log is something completely unrelated. Don't confuse it with the log file.
So when a transaction is committed, it's written to the bin log as well, right?
Right, but that's not transactional. It's just spewed out to the bin log when it's committed.
Okay.
Okay? It's written to the log file in a transactional way because it's written to the log file, it's committed, it's synced. InnoDB will wait until the disk says, okay, this data is on disk, and then come back and say, okay, the commit worked. On a bin log, it just writes it and forgets about it. If you have a MySQL crash, you will not lose committed data out of the log file, provided your disks aren't lying about commits, but you will lose it out of the bin log. You can lose it out of the bin log. The bin log is not transactional. The bin log is something that's part of MySQL, the pluggable interface. The storage engine has its log files. It's got nothing to do with bin logs.
So you could have data in the InnoDB log file that's not in the bin log.
You could have that, yes. You could have that.
Okay.
It's in the bin logs, but it's not on disk maybe because the OS hasn't flushed it to disk. Or it's just not there because it's still in the bin log buffer. But that's not transactional. The bin log is not transactional. The log files are. Yes?
Have you seen any games with the InnoDB flush method or the sync or?
Yes, we have. ODirect is the recommended flush method. That didn't work in earlier versions of Linux. It was buggy. This is good now, and I will cover that in a little bit. Yes.
So you were saying like until the next checkpoint, whenever that is, it won't write to the disk, right?
It will write to the disk. It will write to the log file.
Yeah, it writes to the log file, but it won't write to the disk.
Yeah.
So if another process is trying to read at the same time, it has to read from the disk.
No, it has to read from the buffer pool.
Okay.
That's what the buffer pool is for. The dirty pages are in memory. MySQL, InnoDB knows where to go for those pages. So it's updated in memory, it's committed to disk, but it's in the log files, it's not in the data files. That will happen at a checkpoint. So the data files are basically static, they're sitting there without any changes until a checkpoint. That's the only time data files will change. They might be accessed for reads to fill up the buffer cache, or they might be updated because the buffer pool needs to be flushed because the log files are full or there is not enough memory. But under normal circumstances, no, it doesn't make it to the data file instantly. It makes it just to the log file and in memory.
So how does it know it works in buffer pool or works on the disk?
That you'll have to ask somebody who actually works for MySQL. That's an internal issue. If we could figure that out, we could be writing databases too. These I call hit or miss because there's been so much controversy about these. Some of them have worked in the past, they haven't worked in the past. The first one is thread concurrency. The default is 8, and some people say, in fact even the documentation says, try increasing it, if it doesn't work, try decreasing it. I have seen exactly that. I've seen exactly that in real world systems. You try and increase it, the performance goes down, you try and decrease it, it goes up, or vice versa. It totally depends on a lot of parameters that are a complete mystery to me. And to MySQL as well, obviously. They are trying to improve on this. I believe with 5.1 and with the Falcon storage engine, they are changing the way they adjust concurrency or how they deal with it. But for now, we have to just live with the fact that we have to try increasing it or try decreasing it. In general though, if you look at the system processor usage, if there's a lot of processor usage for system, that might be a good indicator that you need to increase concurrency because threads that are waiting to run will consume CPU. So if you have a lot of unexplained CPU usage, you might want to try increasing it. But like MySQL says, if it doesn't work, try decreasing it. It does need a database restart for that to bounce. So you have to really convince the people that you know what you're doing, which is hard. The other one is InnoDB flush method. If you are running Linux, ODirect is the recommended one. It bypasses the OS cache. What basically ODirect does is when InnoDB opens its files, it tells the OS or the kernel to not cache that data ever, because obviously it's being cached inside of InnoDB. You don't want it cached outside as well. Plus, what that does is it speeds up access, so it actually gives you a little bit of a performance boost, actually quite a lot of a performance boost. But it does still flush the log files to disk, which is where the data has to go. You don't have that in Windows. It's async unbuffered, which is pretty much the same thing as ODirect already, so you're not going to improve on that in Windows. So those are some of the basic parameters that you can tune quickly to get some performance boost. After that, you have to start looking at queries, you have to start looking at your data model, you have to look at show process list, or the slow query log, or the general query log. You have to look at things outside the database. You have to look at what the disk and CPU usage is and why it's like that. Trace it back to the application or your queries. If there's a lot of disk I/O, it means you're reading a lot of data and trying to deal with it, which means probably it's not well indexed or your joins are not good. Talk to the developers. That's something I added in, and I'll tell you why. I was trying to tune this database. It was my ISM, and my ISM should not lock a select on insert. So if you're only inserting data into a table, it's supposed to go in at the end, and the select will still keep running. Except that for this database, we saw the selects being blocked by inserts. I talked to the developers and they said, no, we never delete data out of it. No, we never ever delete data out of it. It's always kept. It's just historical data. It's an insert-only table. And it just didn't make sense to me. And then I kept talking to them, and finally they said, yes, we do purge historical data beyond 2 weeks old. Tell me, how is that not a delete, right? Even in their code it said delete. So anyway, when you talk to the developers, you learn these things. And since I knew now there were deletes, I said, let's look at concurrent inserts and set that to 2, because, okay, I haven't covered that here, but concurrent inserts basically lets you do inserts into a MyISM table without locking the table. You can change that. The default behavior is to allow you to do that, but only if there are no holes in the table, which means there are no deletes. A delete leaves a hole, and a subsequent insert tries to insert into that hole, in which case it needs a full table lock, and that will block the select. But if it goes at the end, then it doesn't need a full table lock, and that will not block. So you can change that behavior by setting concurrent inserts to 2. And what that does is, if there are holes in the table and nothing else is accessing the table, it will fill those holes. If there are holes in the table, but somebody is reading from that table, it will immediately insert at the end of the table and go out, and it won't block the selects. So chances are your data might grow, your table size might grow, but in this application, I know the only time they had a problem was when somebody was querying the data, which wasn't all the time. So we got away with it because we could say, all right, when somebody is querying the data, insert at the end. At other times, fill in the holes, which is concurrent inserts equals 2. So that's what talking to the developers gives you, because sometimes you get insights that you won't see on the database. One other tip that can help you tune effectively is deltas. And what you can do is look at all the status output that I have talked about over a period of time. So when you make a change in a specific area, track that status variable over a day, a week, whatever you have. And that will tell you how your tuning affected the database. Is it going down? Is it going up? Is it going up faster than it was before? Is it stable now? You will see things very easily with open tables, thread cache, or threads created. It'll be a little harder to check for joins or sort buffers, but you should be able to see some effect on that as well. And there's some sample scripts and outputs if you want to go look at that. So we covered some major parameters. We covered how to tune. Any questions? tuning doesn't stop here, it goes on. This is a very basic, it'll give you at least 90% of the parameters that can be quickly tuned. The rest of them will probably give you another maybe 5%, 10%. So if you're really into that level of extreme performance, you can look at that. But beyond that, if you've covered most of these parameters or all of these parameters, then you really need to look at your application, you need to look at your queries, you need to look at your hardware, you need to look at scaling out in a few different ways, you need to look at replication, distributing reads, data partitioning. I think there's been a lot of talks about that. There will continue to be, because there just isn't a magic bullet that will solve all problems. This will help you. If you have a default setup, this will help you. If you still have questions after this and you want to contact me, I will be in ballroom G. Our salesperson Martin is going to give you a little bit about the company I work for, Pythian, because we do remote DBA services. So if you want to know more about that, or if you have any questions, I'll still be available for the next hour. If not, catch me anytime during the session or at the conference. I'll be here. Yes? Oh, the slides. Yes. If you go to this URL here, is it readable?
Yes.
Yes? It's www.pythian.com/blogs. The slides are the first post on it right now.
Can you read the URL?
It's www.pythian.com/blogs. Let me actually do that for you. Not really. But I will put that here. There you go. You can download the slides at the last URL.